In this video, we're going to look at some data from a U24-001 in a freshwater deployment. We're also going to look at some data and post-process some data from a U24-002C in a saltwater deployment. We deployed the U24-001 in a drainage pond. Here in this image, you can see it's right next to a very busy road. It gets all the drainage from that road as well as the onset facility parking lot. It's been very dry, so this pond is quite low. Right now it's about 7 inches or 18 centimeters deep, and when it fills up, when we get rain or in the springtime, it'll go up to over 1 meter deep. So we put this U24-001 in a protective housing. We mounted it on the bottom for about a week, and we logged the low range on that conductivity logger. We've opened that drainage pond file here by going to File, Open Data File, and we're in the plot setup screen. We can see we just logged the low range, and we have the temperature channel here in degrees F. I'm going to switch that to degrees C just for clarity. And we want to process that running the conductivity assistant. So we're going to click Process. We want to select for our temperature compensation, we're going to select nonlinear natural water compensation, which is for fresh water. We're also going to choose to create the series called specific conductance. We are going to use a starting calibration point. Again, it's a very short deployment, so we don't have to worry about fouling. So I'm going to deselect the ending calibration point, and I'm going to put in my measured values that I measured when I was out there, 129.5, and the temperature I recorded at the time was 14.5 degrees C, and we're going to correlate that to a point in the data file. We want to make sure that the logger was stabilized to temperature. Again, we took that measurement at approximately 9:30, so we're going to correlate that with that measurement right there. And we're going to click on Create New Series. Now we have our new series called Specific Conductance. So there's our original raw data, our temperature, and our created specific conductance based on that calibration point and on the temperature compensation. Let's click on Plot. And there is my data. So we can see here, here's my raw data. Again, we're logging every 5 minutes or so. And here's my temperature and my specific conductance. So we have it in our data table. If we click on what we call the details pane and click on the specific conductance channel, there's a selection that says conductivity compensation parameters. We can click on that, and it gives us all the information about the values that we used for that starting field calibration. Again, we're calibrating the data, we're not calibrating the logger itself. You'll see there's some spikes in this conductivity data. I'm seeing some spikes up to a couple of hundred or even 300 microsiemens, and this could be related to something getting on the face of the sensor. Although it is a non-contact sensor, sometimes you'll see jumps in it from marine life or something else coming in contact with that sensor. As I mentioned previously, you don't want to apply a filter when you're launching a U24 because you need to post-process your conductivity data to get specific conductance or to apply that field calibration to your data. However, you could now apply a filter if you wanted to know, say, on your calculated specific conductance, if you wanted to know what the maximum value that you saw each day was, you can click on the little filter icon here or click on Edit and Filter Series. And we have 3 filter criteria available: max, min, or average within a specific time period, again based on those 5-minute intervals of data. So I want to see what my maximum specific conductance was in each 24-hour period. Click on OK. And now I have a column that includes one reading for each day that corresponds to the maximum value that it saw each day. So you can see it's kind of a stair-step effect, and again it is reported from midnight to midnight, but it's based on that 24-hour period. If you wanted to see what those were, you could click on the crosshairs tool up here and just click right in the crosshairs for each day, and it would tell you. You can see right here in the column, it takes you to that data point. And again, if you want to save this, you can save it as a project file. For the second half of this video, we're going to be dealing with a saltwater deployment of a U24-002C. So what we want to do is we're going to, we have our logbook open, we have our recorded calibration values that we took with a calibrated actual conductivity meter. Again, this needs to be conductivity, not specific conductance for this data assistant. So we have those values here written in our logbook, including the time and the date those were taken, and we're going to open that file and we're going to post-process it using our conductivity assistant to get specific conductance and salinity. So we're going to go to File, Open Data File, and there's my U24-002C file that I want to process. And we get our usual plot setup screen. By now we should be familiar. If you've looked at other courses, you should be familiar with this plot setup screen, but this allows us to select how we want this data to be presented and what we want it to be presented on the screen so we can interact with it. We recorded data, conductivity data, in the high range only. You can see we can't click on low range because that was not recorded during this deployment. We also measure temperature, and we can choose to display this in either degrees F or degrees C in this plot. Again, this doesn't change how the data was actually recorded in the data file. It's just, again, just for this plot, just for how we want to see it on our screen. Below that are internal events. These are little tick marks, time and date stamped events in your data file that indicate things like when the coupler was attached or detached from the logger. The coupler is what you use to connect the logger to an optic reading device like a base station, an optic base station, or a waterproof shuttle. Also when the USB host was connected and when the end of file marker was written. The offset from GMT, or what they call now UTC, allows you to change the time reference on the plotted data on your screen only. It doesn't affect the original data file. How the original data file was recorded was it used the time from either the shuttle or the computer it was launched from. So by changing the offset here, we're just changing how it's being depicted on the screen, but the original data file stays the way it was recorded originally. So we want to select the conductivity assistant. You'll notice the growing degree days assistant is available. That's only because there's temperature included. HOBOware looks at all the measurements that are available and makes the data assistants that it thinks are right available for you. But for this, we want the conductivity assistant. So let's click on Process, and our assistant comes up. Starting from the upper left, we want to select the data series that we want to process. In this case, our deployment, we only had the high range turned on, so there's only data associated with that high range. If you were doing full range and high range, you could post-process both of those. You do those individually from each other. We want to select what temperature compensation we want to use. The nonlinear natural water compensation is for fresh water. They call that natural water. So we don't want to use that one. This was a saltwater application. It gives you the ability to put in a linear compensation value, a fixed value for sodium chloride, or you can put in some other number if you wish. We want to use the nonlinear seawater compensation, which is based on PSS 78, which is the Practical Salinity Scale of 1978. Below that, we have the ability to choose which series we want to create from this process. We can create. We're gonna leave both of these checked off so you can see what the product looks like. So we're gonna calculate specific conductance and salinity from this data. You can put in user notes, and those will show up in the details pane in the data, and I can show you what those will look like. Let's say, so water notes. I'll show you where those show up. We give you the ability to either use factory calibration or use measured points for calibration. We do recommend to use the measured points. That gives you the ability to calibrate your data to calibrate out any sensor drift or drift caused by biofouling. As we say, you don't calibrate the logger, this particular logger, there's no way to calibrate it, but there's ways to calibrate the data after you, as you're plotting it, as we're doing here. So when we were in the field, we had an actual conductivity meter, and we took samples at the beginning of the deployment and near the end of the deployment. So we open up our notebook and get those values and times and dates from there and enter them here. So our starting calibration point was taken on July 2nd, 2012 at 3:45 p.m. And let me put the values in first. Our first value was 41,500. And our measured temperature in degrees C is 19.25. And we want to make sure that we're going to associate it with a data point where the logger is in the water and stabilized. So we're going to associate it with this data point here according to our logbook. That's the closest one. We're also going to put an ending calibration point in, and that value was 42,200, and the measured temperature was 19. And we're going to associate that to 3:15 p.m. on the 11th of July. And now if we click Create New Series, we'll see in our plot setup screen we have two new series that are in blue in color. One is specific conductance and the other is salinity. And then let's click on that data and plot it. So there's our data. Again, we have our tabular data here. So this is our raw conductivity, our temperature measured. Here's our calculated specific conductance, and here is our salinity in parts per thousand, which is the same as practical salinity units, or PSUs, which the practical salinity scale of 1978 references also. We did put some notes in here. So again, here, if we click in, this is our details pane. We clicked on the salinity, which is one of the calculated parameters. And when we expand on that, we see we have information about the device, about the deployment, what the logging interval was, etc. The series statistics talk about how many samples during the deployment, what the maximum minimum values, average and standard deviations were for that whole deployment. And if we click on conductivity compensation parameters, in case anyone in the future is wondering what did we put in here for our post-processing values, this records them for us so we can review those, make sure those are right. If they weren't right, we can go back and reprocess this data. The nice thing is the raw data file stays intact, so if this isn't done correctly, you can always just close this file, open it again, and reprocess the data, and then when you're happy with it, save it as a HOBO project file. And again, we talked about notes. We did put a note in there that said saltwater notes, so that's where your notes show up here in what we call the details pane. So there's my data over the deployment. We can see from the beginning of the file that the logger was out of the water for a bit. And if we want to make any changes to this file, we can, colors, or delete specific series. If you don't care about looking at the actual conductivity, you can right click on this, select it, and then say hide, take it away, or you can restore it if you want to. And then once you're happy with how this file looks to you, you can go to File and Save Project. And then this saves this file for future reference, and you don't have to reprocess that data again. If you don't save it as a project file, you will have to reprocess it again if you want to know what salinity and specific conductance are for this deployment.